Okay, question 7. Split into two parts. The first part is a fairly standard thing that we have to be able to do. So this is taking 3 sine theta minus 4 cos theta and putting it into the form r sine theta minus alpha. 3 marks for doing this. And so it's a pretty standard thing that they want you to do. You have to know how to be able to do this. The thing to do is to use this here, r sine theta minus alpha. In your formula book, it shows you how to expand this, because in your formula book, you will be able to find sine a plus minus b. Now we're interested in the minus version here. And what we've got in R1 is that the theta is the a and the alpha is the b. And what happens is, if you write the expansion out of this, you will get sine theta cos alpha minus cos theta sine alpha. Now the only difference is we've got an r in the front, which means everything here gets multiplied by r. And what you then have to do is you have to try and match up. So we're looking here and I'm saying, well, this part here's got sine theta, this part here's got sine theta. And so the 3 must be equal to the 3 cos alpha, sorry, the r cos alpha. And on the other one, we've got cos theta and cos theta. It's really important that the thetas are matching up here as well. And what that means is you can see the minus and the minus match, which means the 4 from up here must be equal to the r sine alpha down here. Okay, and as I say, that's a pretty standard way of setting up, and what will always happen, particularly in the example like here where they gave alpha as being between 0 and 90, is they will always give you one here that works in terms of the sines matching up, the coses and the sin matching up as well. Now, the way to get r down here is very simple. This forms always a Pythagorean triple of some sort, so r squared will equal 3 squared add 4 squared. You can always take these two numbers, do Pythagoras with them, and r in this case comes out as being 5. Now you can either then go back to one of these and you could say, well, that means 3 equals 5 cos alpha, or 4 equals 5 sine alpha, and you could work out what alpha was using either the inverse cos or the inverse sine. The alternative is to do this whole equation divided by this whole equation, and that will get you that tan alpha, sine divided by cos, is 4/3, and you can then use the inverse tan button to see what alpha is. Okay, it should come out, I think, as 53.1 degrees in this case. Now we're going to use that in a second on the next question. So, what we're going to do is we're going to remember that this thing can be written as 5 sine theta minus 53.1 degrees. Okay, that's the same thing, just written in a different way. Now, here's what happened in part 2 of the question. We're now given this thing, g equals 17 plus 3 sine 15t minus 4 cos 15t. And the really important thing to notice here is that that section, 3 sine 15t minus 4 cos 15t, looks a lot like what we've just worked with, 3 sine something minus 4 cos something. In this case, the somethings, what were the thetas, are now the 15t's. And what that means is we can rewrite this function g as being 17 plus exactly the thing we had before, but written with the new part that we've just done in part A. So 5 sine, now instead of theta I'm using 15t minus, and then we found out just now it was 53.1 degrees. And that's just another way of writing this first bit here. Now the first part of part 2 of the question, or part B, was find the maximum temperature in the greenhouse, i.e. what's the maximum this thing could ever equal. The maximum this could ever equal, this is 5 sine something. It doesn't matter how complicated this thing in the bracket is, sine can only fluctuate between -1 and 1. And so the maximum this could be would be 17 add 5, which is 22. Okay, this is much easier to do if you spot that you can rewrite this in this format. Now that will almost always happen on a question where you're given something like this to do in part A. It'll be then so that you can rewrite it like that in part B and use it to your advantage. If the question had asked minimum, the answer here would have been 12 because it would have been 17 minus 5. Now part the next part of that, so B part 2, often would be find the time at which that maximum temperature happens. Now, if that had happened, you'd be thinking, well, when does sine equal 1? It's when this stuff in here equals 90, and so you'd be working out when does 15t make that bracket 90. However, the question is actually ever so slightly different. The question is, find the time after midday when the temperature in the greenhouse is 20 degrees. Now, there's a crucial bit there, which is after midday. The original kind of blurby bit of the question said that T was defined as being the number of hours after 5 a.m. So T after 5 a.m. We now want after midday, which means that our answer for T is going to have to be bigger than or equal to 7, because we need to go past midday. That's worth bearing in mind as we go through this question. Okay, anything smaller than 7 won't go above midday. So we're using this thing here, but now we're sticking to equal to 20 because we want the temperature to be 20. So we get 20 equals 17 plus 5 sine, and then our brackets 15t plus minus 53.1. So what most of us managed to work out to do from here is subtract the 17. So we're going to get 3 equals 5 sine. And then we've got that whole bracket again, 15t minus 53.1. And so what we end up with is sine of the bracket, 15t minus 53.1, equals 3/5. Fine so far. Now, when you do your inverse sine here, so you get 15t minus 53.1, equals, and this is where you then look to see what your possible solutions are. So if you do that, you're doing the inverse sine of that, you will end up with, if I check my numbers, and it turns out, the reason I'm taking so long is it turns out I'm in radians mode. Worth checking that. 36.9 degrees. .9. Okay. Which is okay, other than I can see already, if I add on 53.1, that's actually going to give me exactly 90. Divided by 15, that's going to give me 6. And 6 wasn't okay. 6 won't take me past midday. And so what I need to think is, at this stage, what are my other possible answers? Well, this means, think about my sine graph. Here's one answer. The other answer is coming back from 180. So it might also be that 15t minus 53.1 equals 180 minus 36.9 degrees, which is going to be 143.1 degrees. Now if I use this one, this gives me 15t equals, and then I'm going to add the 53.1, so I'm going to get 196.2. And now when I work out t, that comes out as whatever that comes out as, 196.2 divided by 15, I've ended up with 13.08. Now I've used slightly rounded numbers there, so that might not be absolutely perfect, it might be ever so slightly different. All you have to do from now is you now need to work out how does that translate into hours and minutes. Well, 13 hours is okay. You'll need to do 0.08 times 60 to work out how many minutes it is, and your absolute final answer should come out as being 5 extra minutes. And so what that means is our final time is 6:05 p.m. Okay, but the crucial thing here was, although this was the answer you got from doing inverse sine of 3/5, that number there doesn't give you a t-value that's bigger than 7. It doesn't take you past midday, and so you actually had to carry on the sine graph to get the next t-value here. That's still a possible 15t minus 53.1. You still had to work with that number to get what t was, to then finally add on to 5 a.m. So this was 5 a.m, add 13 hours plus 0.08 hours to get 6:05 p.m.